Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 2 of the April Daily Leetcode Challenge. We have easy question now. Yesterday's question was a really good one. Please do and try that. It was a very good question on the DP topic. And today again we are having a very good question, though it is marked easy, but I will show you the approach, which you can see the constraint basically. It's around 100. Okay. So I will show you the approach which will work even for 10 power 5 range. Okay. So I will show you that approach because my approach is going to be around often first present time complexity, right? Normally you can solve it using off and cube approach also, but again that is not something that see, you can try that, obviously that's a brute force approach, but in this solution I have really shown the most optimal approach in which using of and type. See, this is something that you can, that we can expect something from a candidate in interview, right? See, there are some tricks also to make even like reduce it further, like we can avoid the space complexity altogether, but again those are something that should be coming as an add-on. Okay, that should not be your first solution. Your first solution should be, would be, you can try for a brute force, but again in this case brute force is not acceptable at all because it's of n cube. So yeah, for it and 10 per 5 range, I can say for a 10 per 5 range, the first solution that I can accept from a candidate is going to be ofn. Okay, ofn or ofn square. Okay, maybe any one of them could be fine. Okay, but next step should be you have to reduce the space complexity further. Okay, so yeah, in this question I will be showing you the ofn time and ofn space approach. So let's quickly go to the question. It's question 2873, maximum value of an order triplet. So what you have to do is, it's very simple. What you can choose, you have to choose three indices basically. Okay, you have to choose three indices I, J, and K. Okay, such that I is less than J and J is less than K. Okay, idea here is, see, when we say three indices, they should not be same. Okay, all the three indices should be different. That is the first condition. And I should be the smallest index. They should be in between that, and K should be altogether largest. Okay, now for all such triplets possible in this. Okay, see, remember, when we say triplets, it need not be a sub array. Okay, many people think, okay, we have to select a sub array, something like that. Okay, it's not about a subarray. You can choose any way. Okay, you can choose any way. It's kind of a subsequence, you can say. Okay, a subsequence of length 3, I can say that. Okay, for example, 12 can be here, I can be this particular number, J could be here, and K could be here. Okay, something like that. So what you have to do is you have to find scores of all such triplets. Okay, so the value of a triplet, yeah, they are calling it as a value, right? They're calling it as value. The value of the triplet they are saying is it is equal to nums of I minus nums of J into nums of K. Okay, so the whole question is going to revolve around this particular topic. Okay, so you have to observe this thing very very keenly. Okay, then only you will be able to get some idea. And one very important other aspect that I want to tell you, that see, this condition is again very very important. See, there are some things. See, I will say that again. See, the question, especially for this kind of questions, the solution comes by observing these small things. Okay, I will tell you why this works. See, here they are clearly saying we don't want a negative answer. If at all the negative answer is coming, return zero. That is the first thing they are saying. One more important hint is that, see, all the numbers are going to be positive. That it need not be negative. Okay, it cannot be negative. Okay, as simple as that. That is the reason why the approach that I'm going to show now will work. Okay, otherwise if you see what is happening, there is a multiplication involved. Okay, so the idea here is, if this number is negative and this number is also negative, then again you will get a very big number. Okay, you will get a positive number again. Okay, so those kind of possibilities are eliminated here because they are saying, see, nums of any one of these three cannot be negative. Okay, the idea here is nums k definitely it will be positive only. Okay, that one thing is very clear. Yeah, because of a subtraction it may become negative, but nums k is always going to be positive. Okay, first thing. Second thing is that if the values are coming as negative, you have to return zero. That means if this particular value becomes zero, if the subtraction becomes zero, obviously the answer is going to be zero. If this subtraction becomes negative, the answer is always going to be zero because we did not return any value less than zero. Simple as that, right? Now, how to solve this question? So, whole thing is going to revolve around this. See, my request to you will be, go through the example 1, 2, and 3. Okay, they are giving some very good examples, so go through it. But I am here to tell you how to understand the question, how to develop the logic building steps. Okay, what all you have to explain to the interviewer when you when you're asking such a question. So, the thing that I can say is that, see, you have to give you full focus on this particular formula. So, what all you can optimize here? See, the first thing that we can do is we can try to maximize this particular subtraction, because if the subtraction result is larger, the final result will be larger. That's the first point. Second point is that nums of k should be as much greater as possible. Okay, so how to achieve all of this? Okay, so the solution that I am going to shoot is going to O of n times. See, what we are trying to do is, I am going to pre-calculate this particular value. Okay, that is, for any I and j. Okay, for any I and j, what I'm going to do is, see, obviously I is going to be less than j, so j is going to be the, see, with respect to j we have to calculate the k. Okay, so j is the j is fixed. That means we have to choose a case such that it's greater than j. Okay, so what we are doing is, for every j basically we are calculating what is the next maximum. For example, so let us see, if j is here, from this particular index I need to know towards the right what is the next largest value available. Okay, that is, if this particular 6, okay, it's at present index number 1, let us say j equal to index 1. Okay, so we need to know the value which is towards the right of j, which is largest. Okay, so what we have to do is we have to encache that value. Okay, so how I'm doing that, for doing that, I am creating this particular array. Okay, max element at right. Okay, so what I'm doing is, initially all the values will be 0. Okay, then we will go in the reverse direction. We will change those values. I will show you how it looks. So yeah, let us quickly begin. So let me take some bigger example. Okay, see. So what we'll do is for every index, basically, let us say this particular index, what we'll do is see from, let us say I am at index number j. Okay, so from j plus one onwards towards the end, okay, j plus one onwards till the last element, it will tell us which element is the highest. Okay, for example, in this case, if you see, we are at 10. Okay, so this index number 2. So it will tell from index number 3 onwards, which is the last element. Okay, so in this case, if you see, these are the elements from which you have to choose, and obviously 19 is going to be the largest. Similarly, if you talk about this particular element, so here it is index number 2. So index number 3 onwards you have to choose, and again 19 is going to be largest. Similarly for 4, 19 is going to be the largest element. Okay, towards the right, we have to choose the largest element. Okay, so if we are at index number I, we need to choose the largest element from I plus 1 till n minus 1. Okay, that is the basic idea. And obviously for last element, we cannot choose because see, there is no element over it, right? So this will remain 0. And for the first index also, I am not doing that because if you see the constraint that I have given, I don't want to calculate this because I will tell you the reason. See, the loop, the way it is run, it will stop at I equal to 0. Okay, it will not process the I equal to 0. The idea here is we don't need that because see, I if you see this constraint, right, so we do not need that value. Okay, because j by itself, see, j will take index number 1 because j can never be index number 0. Okay, that is the reason I don't want to fulfill that value. Okay, as simple as that. That's why always the first value will remain 0 because we are not even calculating for this part. Okay, now what we are doing is, see, this particular value will try to maximize. This value will be, for each iteration this value will change, and this value we have already calculated. Now let's see what we are doing. Okay, so see this part. So till this part I have explained you. Okay, we are creating array, we are filling it. Okay, now start the most important part. See, max now equal to, okay, let me make enter. Yeah, now max equal to nums of 0. Okay, now what we are doing, this particular max will be this. Okay, nums of I is basically now being represented by max. Okay, so this max will be, calculated for every iteration, and only the largest value will be taken forward to the next iteration. So our answer is starting with 0 because the minimum possible answer that we will return is 0. So that's why I'm starting it with 0. Then I am starting from index number 1 till n minus 2. Okay, I'm starting from index number 1 till n minus 2. Why like that? See, idea here is, see, this whatever loop I'm going to run now, this will be, representing my j. Okay, so j cannot be 0. Similarly, j cannot be the last element because see, obviously there has to be a element which is greater than j. Similarly, there has to be element which is less than j. That's why it's going to be starting from 1 till n minus 2. Okay, now what I'm doing, see, answer is equal to max of the previous answer, comma, now this is the value that we are going to calculate. So please pay attention what we are doing. See, I'm doing max minus nums of I. Okay, what I'm doing max minus nums of I. What is max? Max is basically till now whatever values we have seen among them, what is the max value? Okay, that is going to be the max minus nums of I. Okay, this nums of I is basically going to represent your nums of j. Okay, as simple as that, right? Then we are multiplying it with max elemented right for I. Okay, so this particular value that we are going to get is, for getting this, we are going to use this particular loop. Okay, max limited right. So among all the elements towards the right, I'm going to choose the, biggest element. Similarly, among all the elements from towards the left, I'm going to choose the largest element. Okay, among all the elements we have seen till now, we are going to choose the largest element. Okay, so this is going to be our max, and this will keep changing for every iteration. But yeah, these values will change only when we get a bigger element. Okay, as simple as that, right? And then whatever answer we are getting, that we're storing it here, then we are updating the max. Okay, for the next iteration we are updating the max. Okay, so since nums of I is not considered as of now, so we'll make that consider now. Okay, see, it is max is compared with nums of I, whichever is greater, that is now being stored in max. So this max will now be used in this particular place. Okay, in this particular place this will be used now. Okay, and finally return the answer. So let me quickly run this and show it to you. As you can see, this is clearing all the test cases, and yeah, this around, it is taking 1 to 2 milliseconds. It is beating around 90% of the test cases in Python. I mean 90% of the solutions in Python. So it is often and often space complexity. If you see, we are creating array, that's why it's often space complexity. And other than that also, if you see, we are using 2 iterations. I agree with that. Yeah, this iteration, and if you call this also as iteration, fine. But yeah, this is often only because we are using 3 iterations, or each one of them is going to often only. Okay, so often that was all for this particular video, and it was often time and often space solution. Now see, the next thing that you can think of is, currently we are pre-calculating this particular value. Okay, but the idea here is, do we need to pre-calculate that? Okay, in this iteration itself, maybe what we can do is, we can try and see among all the values that we have seen, we can take the max forward. Okay, that is something that we can do. So you can try that. Okay, what you have to do is, you have to maintain O of n only, but you will have to avoid taking this array. That is, we want O of n solution in terms of space. Okay, but in terms of time, it will be O of n only. Okay, so we have to reduce space complexity to O of n, O of 1. So you can try that out with the same steps. What you have to do is, at this particular step, basically here we're directly taking value. Here you'll have to introduce another variable, and that variable keeps changing. Okay, that variable keep updating, like this particular max that you have to do. Okay, so yeah, that was all for this particular video, and yeah, please try that and let me know. See, the answer is already given, that's why I don't want to stress too much on it. See, my aim here is to show you what you need to present in an interview. Okay, that's why I'm mentioning when this kind of question comes. See, if you give a brute force kind of solution, that is going to waste your time as well as the interviewer's time, because see, for those kind of solutions, definitely you will not be selected for this kind of questions. Okay, that's why, though it is easy question, you can go to off and cube and get away easily. But believe me, if in the interview this question is asked, you will not be selected with off and cube or off and square solution. Okay, you will have to bring it down to off and at least. Okay, because that is possible and that will be expected for you. Okay, so yep, that's why I'm mentioning this is something that you can show it to the interviewer. Definitely this is a good starting point. Maybe you can add some more optimizations here and there, or you can even try and reduce the space complexity further. That also you can do. But again, that I don't expect a candidate to show a first solution. That could be a follow-up solution or something like that. Okay, as a second solution maybe. So yeah, that was all for this particular video, and see you tomorrow. Thanks a lot.